So let's look at 14. It is 4 minus 5i plus 4 minus 2i. Now, I, because it's a radical, follows the same rules as radicals, and we said earlier that radicals follow the same rules as variables. So combining like terms. So that's all I'm going to do here. I have 4 minus 5i plus 4 minus 2i. Combine my like terms. I've got 4 and 4, so I get 8. And then I have minus 5i and a minus 2i. So minus 7i. And that would be my final answer. Like terms. That's all we did, was we combined our like terms. Just like we would. In this case, we are kind of treating I as a variable. Okay, it's working the same way.
But if like terms don't consider that both of them are negative numbers, say if it was in the problem.
They're not like terms because they're negative. They're like terms because they both have the I. So if one was a minus 5i and the other one was plus 2i, we could still combine them. Okay? So that's an adding one. I believe you have a subtraction one. Yeah, number 3 is a subtraction problem. And you know, subtraction works very similar to addition. You just really have to watch your signs. So this one is 3 minus I minus 8 plus 5i. So you could do this a couple different ways. If you remember that you have to subtract everything in the second set of parentheses, then when you combine your like terms, just think 3 minus 8, but then it'll be minus I minus 5i. Or you can just do a real quick rewrite, because remember, all of your subtraction problems you can rewrite as add the opposite. So if we add the opposite, I would keep my first term and then add, and the opposite of 8 is negative 8, and the opposite of 5i is a minus 5i. And then I can combine my like terms from there. And you can put parentheses around that if you like.
And that's because the negative sign is in front of the other sign.
You can rewrite any subtraction problem as an addition problem just by adding the opposite. So then this will give me my like terms. Let's see here, 3 and a negative 8, that's negative 5. And a minus I and a minus 5i would be a minus 6i. I could have got there without rewriting it. I just have to remember that it's 3 minus 8, which is minus 5, and minus I minus 5i, which would still give me the negative 6i. So we're kind of distributing, if you want to think of it that way, that negative sign or that minus sign. Because all I did here, I added the opposite. From that first step to that second step, I just rewrote it as adding the opposite. So you'll notice all the signs in my second set of parentheses just changed. And then I could combine my like terms. So that's adding and subtracting with I. Let's move into some multiplication with I. Let's do 19. Ooh, and we can do 20, and then we'll come back and do that FOIL. So let's do 19 next. And you're thinking, well, that doesn't have I in it. Yes, it does, because it's got a negative under the square root, which is I. So 19. I have the square root of negative 7 of negative 3. Now, what you're tempted to do is to go, oh, well, negative 7 times negative 3, they're both of them a radical sign. Let's just multiply them, and a negative times a negative is a positive, right? That's when you're talking about real numbers. Okay? We're not dealing with real numbers. We're dealing with I. We're dealing with imaginary numbers. So we actually have to simplify first before we can do that. So let's just rewrite this real quick. Instead of the square root of negative 7, I can actually pull out the negative. Whenever you see a negative under the radical, that just translates to I. So this is really I square root 7 times I square root 3. That's all it is. Now, I can multiply the 7 and the 3 and get what? I can get the square root of 21. What's I times I? I squared. Okay, we haven't dealt with an I squared yet. And now's the opportunity to deal with the I squared. Because guess what? That's not our final answer. I squared can be simplified. And you're thinking, how can I squared be simplified? Well, remember that I equals the square root of negative 1. What happens when you square a square root? Nope, it doesn't become a positive, but remember a square and a square root, aren't they opposite operations? Don't they cancel each other out? So if I go in and I square this and I square this, I get negative 1. If I is the square root of negative 1, then I squared is negative 1. So I is an imaginary number, but I squared, it's a real number. It's like the AT&T commercial. So what that means is whenever you're working with I and you're multiplying and you get I squared, you can always replace that with a negative 1. So this really means negative 1 times the square root of 21, which we can just say is negative square root 21. Let me carve out some space here for 20 because it doesn't take up a lot of space. 20, square root of negative 19, expressed in terms of I. How would we write that in terms of I? So if you did negative 1 times 19 underneath your radical sign, remember the square root of negative 1 is I square root 19. That's all that one is. Now any of these negative ones, or these I problems that we've done, if you do square root of negative 7 times square root of negative 3 in your calculator, it will pop up negative square root 21. And if you were to plug in to your calculator square root of negative 19, it's not going to give you I square root 19. And it probably, well, and I take that back. It probably won't give you square root of 21 either, because you know what it's going to do? It's going to give you the decimal of square root of 21. It's not going to give you, so what your calculator does is it won't simplify radicals. It will put them in decimal form. So that's why, you know, when I said, oh, you can do I in your calculator, you're like, that means I don't have to learn it. Well, yes, you do, because it won't simplify the radicals for you. Now, yeah, if you had like if you did square root like what we did before, square root of negative 49 and it popped up 7i. So if it can simplify, if it can take the square root of a number, it will. And it'll throw the I in there. And it'll go ahead, and even if you put in the square root, what was that, square root 21, it'll put an I there, but it'll have the decimal equivalent and then an I at the end. It won't say square root 21i. So, okay, so let's do this problem, and it's a FOIL problem. So we're going to do the whole FOIL process. You can put it in your calculator, and it will give you the same answer we get by doing it this way. It's a good way to check your work. So, let's practice FOIL. So first outer, inner, last. My first terms are 3 and 3, so 3 times 3 is 9. My outer terms, 3 times I, so that's 3i. My inner terms, 4i times 3, so that's 12i. And finally, my last terms, 4i times I, 4i squared. So let's go through and simplify what we can. I can definitely combine some like terms here. So I have my 9 in the front, 3i and 12i is 15i, and I have plus 4i squared. Now remember what we said earlier about I squared? It's negative 1. So we're not completely done yet. So this is really 4 times negative 1. And 4 times negative 1 is negative 4. And I'm showing all my steps. You'll probably end up skipping some of these. And then I can combine my 9 and negative 4, which is 5. And now that's my final answer.
Hold up. When you have the 4 with the parentheses and a negative 1,
Uh-huh.
how come it's not squared? It's squared up there?
No, I squared equals negative 1.
Oh, okay.
So whenever you see I squared,
Yeah.
replace it with negative 1.
I have a question.
Yes.
How did you get 3i on like the top?
Here. Let's see here. First, outer, inner, so that was my outers. So 3 and I. The 3 on the far,
okay, never mind.
and then the
Now
I.
see it.
Okay. Now you can put that problem directly in your calculator, exactly the way you see it, parentheses and all. Parenthesis. In fact, I want you to go ahead and do it and see what you get. It's a good way to check, and I highly recommend that you do it to check. But if you put it in there, did you get 5 plus 15i?
Yep.
Woohoo! And this will also give you some practice putting it into your calculator. And what I really like to do in my calculator is check my division, which we're getting ready to do a couple division with I here in a minute. But we can foil anything we can do with variables, we can do with radicals, and we can do with I.